welcome to my channel again. Today we want to see how we can get soil moisture data from Google Earth Engine. You know, soil moisture data is the data is we're looking at the content of water within the soil. So, how we can get this soil data from Google Earth Engine. So let's dive into it. And what we're going to be using, the data we're going to be using is this NASA GLDA data. But let's check it. That's Global Land Data Assimilation System. That's GLDA 2.1. That's data we are going to be using. You can search for it. And this is it. Let's look at it. Now you have this data. This data we are going to use. That's GLDA 2.1, that's Global Land Data Assimilation System. That's the data we are going to use, and the data started from availability started from 2000 year 2000. That's 1st of January year 2000. That was when it started. The dataset provider, I said, is from NASA GS Disk at NASA Goddard Space Flight Center. It's from NASA, and this is the collection snippets. Now you see what kind of data, the type of data you can get. You can get 3-hourly climate data, evaporation data, forcing geophysical data, GLADS data, humidity, EDAS, NASA, precipitation, pressure, radiation, soil moisture, surface data. You can have temperature, wind. So these are the different formats of data you can get from this data. It's a very rich data, and it's a global data, so it covers the whole head. So that means you can have this data from any part of the world where you are. Now you say this is the description of the data and the bands. We have the resolution of the date of this data is 27,830 meters. That's the resolution of the data. You have these are the bands. You have the albedo, and we have the surface temperature, surface skin temperature. We have the plant canopy surface water. You have the canopy water evaporation. You have a whole lot of water, direct evaporation from bare soil data. You have it. This is the band, but we are potential evaporation rate. You have the data. It's a rich data where you can have a rich a robust data collection system where you can have most of your data within it. So these we have rainfall, total precipitation rates. We have the groundwater runoff, space flow, rainwater runoff, snow melt, and all that. Now, but we are looking at the soil moisture. So this is the soil moisture data we have at 10 centimeter beneath the soil level. The soil moisture at 10 centimeter between the soil level. We have the at 40 centimeter below the soil level. We have at 100 meters, we have at 200 meters, and we have the soil temperature data also at different distances down the soil level, and all that. So what we are going to look at is, today we want to look at 10 centimeter, but we are sure that if you want to have different maps of different maps at different centimeter, all you have to do is copy this in the scripting. You will see where we are going to use this 10 centimeter. So if you are interested in 40 centimeter down the soil, you come here, copy this copy the band, and put it there, put it in the scripting. If it's 100 centimeter beneath the soil, that's the data you're looking for. You come here, copy it, and insert it there. So that's that. So let's dive into it. Now I want to look at Lagos State, Nigeria. So this is the shapefile of Lagos State. So I'm using Lagos State as a shapefile. I want to get the data for Lagos State, so I'm just going to call it in. 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 So I'm just going to call it and a stable, I'll put it as area of interest, AOI, area of interest. So somewhere in the scripting I have the script of soil moisture. Okay, there is it. I call it up. Yes, so there is it. We have data set. This is the data set. This is it here. And if you look at the SnipNet, like we said the other time, you just copy this. You can copy like this and close, or you can say import. Then if you copy, then you can close. If you don't copy, you can import. So I close and exactly paste here. So this is it. So this is it. Then we're going to say the area define data set. So we have defined the data set. You now say define area of interest. Now I don't want this area of interest. I want my Lagos State Sheppard to be my area of interest. I delete this and as AOI, and I have my AOI, I guess. Okay, it's not there. Let me bring it back. Assets, Lagos, AOI. We need to define our AOI. This is our AOI. Okay. So in the scripting, the first thing is I want to say filtered by date and AOI. We want to filter by date and area of interest because it's a global data. So you just want to filter the data by the date, date that we want now within the year that we want, and also within our we want to filter it by bounds too. So by our study area of interest, which here is Lagos State. So we say VAR filter dates. To filter dates, this is the script. VAR filter date equals data set. This one can be, you can change this one to dates, depends on what you want. It's not necessary you use filter date for your own data set. You can just say VAR date, but just what you can understand. Just put what you can understand. But this script should be, should be dates. So this one can be anything: filter data, data set, filter date, filter. Just give it what you like. So here we say dataset dot filter date. We open a bracket, then this sign, don't forget, like inscription sign. Then we say 2001 that's 1st of January 2021 to 31st of December 2021. Then here we are filtering our AOI. We say dot. We are specifying that we just want our AOI area, the area of our interest. That's what we are looking at. We are not looking at the global data. We just want our region of interest, area of interest. So we say filter bound. That's filter boundaries to our area of interest. But the script doesn't understand if you put filter boundary. You just say filter bounds, then open a bracket, AOI. Just call this one in. If I change this to ROI, let's see. If I change this to ROI, you see that it changes to ROI directly here, and even here it changes to ROI. So let me leave it at ROI. So what we're going to do is this, and even here it changed to ROI. If you put it back at AOI, then all where you have ROI will change to AOI. You see, this one changed to AOI, it's changed to AOI, and here changed to AOI, and here changed to AOI. So we can leave it AOI. Just understand that once you change the name here, it should affect your where you have the names there. But if it doesn't affect, then you should understand that there is something wrong with your scripting. Your scripting is not correct. If you change this name and it doesn't affect those places where they don't change automatically, at those areas where we are calling them out, this data set out, then know that your scripting is not correct. So we filter by boundary, our AOI. Then now we want to say, select the muster index band. Remember I told you the other time there are different bands, and we are going to be working with 10 centimeter depth of this from the soil. So we say VAR, that's for the scripting for selecting the moisture band that we want to work with. And I'll say VAR soil moisture equals filter dataset dot select. We say we want to filter the data set, and we want to filter all the bands dataset of soil moisture data, filter all of them, and select this soil moisture 10 centimeter inch. If it's this other one, let's go back. Let's see. From the bands, from the soil, soil moisture. Now we just copy this, copy, then you close, then you come here, you paste. Or if it's 20 centimeter down soil moisture, if it's 40, you just copy this. So once you copy this, you are copying the band. If you copy this, you are copying this band of 10 centimeter. If you copy this, you are copying this band automatically. So but today we want to work with the, so for instance, maybe in your work, the work you're doing, you have to show for the moisture content of the soil at 10 centimeter, you have to show at 40 centimeter. Then you use the same script, but you copy at 10 centimeter to that you want your filtered data to select at 10 centimeter, you copy this. If you want it to select at 40, you copy this. At 100, you copy this. At 200 centimeter, you copy this. So that's so you can make series of soil moisture at different centimeter depth against the soil. So here we are saying we want to have here 10 centimeter depth, so we copied the 10 centimeter data band data, we copied it here. Then we want to say, since it's only one data set we want to download, we are not downloading for January to December. Understand that this is January, this is December. We are only saying collate all the data sets within these dates, within January and December. If it's a daily data, then that means there will be data per day. If it's hourly data, that means there will be data per hour. But now we will just want data within this date, just one data. Then we are going to run an average. That's the mean. Calculate the mean soil moisture over the year. So we want to, from January 1st to 31st, January 1st, 2021 to 31st December 2021, you want to calculate the mean soil moisture over the year. So you say VAR mean soil moisture equals soil moisture dot mean, open and close the bracket, dot clip AOI. Here there is difference between filter bounds. There is difference between clip and clip. Filter bound is just run this analysis, this small analysis, select just our area of interest. But now clip is you are clipping it out, you are copying it out. This one only selects the analysis of this date, of taking this date within, and filter, just let it be within our area of interest. We are just interested in this data set within this date at the level of our region of interest. Now this clip says copy this data out. So after you get the mean, you don't clip before mean. You mean it, that's you find the mean soil moisture before you now clip the mean soil moisture of your area of interest. Now divine visualization, the minimum value is 0, maximum value is 0.5. Let's see again if the information is there for the 10 centimeter. Okay, it's not there. Let's see. Terms of use, citation, parents. Okay, the minimum value is 0, the maximum is 0.5, and we choose 3 color ramps, the blue, green, and the red. Now we say here, center the map on the AOI and add the mean soil moisture layer. This is what we are doing here. Center the map on the AOI and add the mean soil layer. So this one is the first. Center the map on the AOI. This is it. Map.center object of AOI at 6. Maybe I want it at 10. You can change this number, maybe at 12, at 10, at 20. Let me put it at 10. This value here just tells you how you want to visualize. You want it to be small, visualization or you want it to be bold and all that. So you can switch. You can change this number to suit your own how you want to visualize it on the mapping interface. So this second one is add the mean soil layer, and this is map.add layer mean soil moisture. That's this. This mean soil moisture is this already. Soil moisture dot mean. That you found the mean and you have clipped the AOI, and all this goes into mean soil moisture. So if you now want to call out all this after, all you just need to do is to call this to represent it. This is the representation of this function. Soil moisture, that's the mean of the soil moisture, and clipping of the AOI of soil moisture. This represents it. This represents it. Okay, sorry. We remove this. I need to define this. Okay. So this one goes. Okay. So we call it out there. Add this function and add this function, and the function is set the minimum and minimum value and maximum volume this, and name it mean soil mixture 2021. And then we said add the AOI of the map for visualization. Add which we want to perform this function. Said map.add layer AOI color, open this, color red. We only want it in red. If we don't want red, you can say color red. Let's put 2 colors. We can say red. We can change the color, say green. You can give it any color that you want the outcome to look. But let me put it in red. Then here and then red, then your AOI, time it AOI. Export, you export this and the it's in 10 kilometer. You can scale it. I decided to scale it at 10 kilometer resolution because it's a high resolution data. So for you to be able to visualize it quickly, because it drags, because it's high resolution. So you don't give it 30 minutes. If you give it 30 minutes, it may take a long before you can view the data on the mapping interface. So that's why I give it 10 kilometers so that I can see it quickly. And your region of interest of region, you choose AOI, max pixel, maximum. Just give it a maximum number of pixels that is possible, and then let's run it. Let's see. Because I put map.center_object to ROI, it will automatically come to that area of interest. It's once you run, it comes directly to the area of interest. So I think the task is blinking. I think it's there. Okay, we have our AOI, we have our Musto, soy Musto, mini soy Musto 2021. Now, one way to validate that you have your data, that your data is, you have data in your for your analysis. So this our AOI. I think we don't need it. We remove it, and let's see the. I'll remove it. Then let's see this. Click this. Now you see the range. The range is if this one is empty, that means you don't have any data. You don't have data. It's either your coding is wrong, that your scripting is wrong, or the data does not exist for that year, or the data does not, doesn't have a band for that location that you are talking about, or something is wrong generally. But here we see that the range is 0 to -5 to 0.5, what we set here, minimum and maximum. So, and if we are looking at SoyMosto data, SoyMosto, the data always start from 0. That's the lowest, start from 0, and the highest is at 0.5. That's if it's at lowest, that means it's very dry. The soil particle is very dry. There is no moisture in it, and as we have moisture in it, it graduates to 0.5. So the value ranges from 0, which interprets no moisture, and 0.5, which interprets we have highest value of moisture. But there will be a kind of we still have, once you run it on your, once you download the data and you process it on your GIS software, maybe you have GIS or QGIS, you can now run, you can see that there are still values between 0 and 0.5, and as the value increases away from 0, that means as the value increases from the 0, which signifies no moisture, then you can classify it as no moisture, average moisture. Just find a way of classifying it to 0.5. Then you can have the classes of the availability of moisture on your data set. So it's still taking time. You still have to fill all this. I told you from the onset that the data is very robust. It's very robust. It's very heavy. So it takes time to load, and you can imagine how much time it's going to take to download. But if you want to download this data, all you have to do now, this is an assurance that you have the data. Once you have the range input automatically on the here, so you are sure that you have the data. So you just close this. If you want to see it again, you come here from the layers, you check it, and you click this. So now looking at the task, let's go to the task. You have it already, mini soy Mosto 2021. All you do is just run it. Once you run it, you'll be able to download it on your Google on your Google Drive. You'll be able to download it on your Google Drive. Then once you download it on your Google Drive, then you can upload it on your GIS software, ArcGIS, QGIS, and the likes, and then you'll be able to process it further to make a complete map. So thank you, and God bless you. We are able to show how we can use Google Earth Engine to to get to acquire the soil moisture map data from from the global data, or other global land data assimilation system. Thank you. Subscribe to our channel so that you can be updated when we have new videos on GIS and remote sensing. So thank you very much, and I'll see you next time. God bless you.